Alrighty, so in this section, in 3.4, we're going to be talking about linear inequalities in two variables. So we want to learn how to graph this linear inequality. Alright, so the first thing that we want to do when we're graphing linear inequalities is we want to write the inequality in slope-intercept form. Okay, so that's y equals mx plus b. The only difference is that we don't have an equation, we have it in slope-intercept, or we have it as an inequality. So instead of it y equals, it'll be y is greater than or y is less than. So let's write this in slope-intercept form by solving for y. So I'm just going to rewrite this right here. Alright, so let's solve for y now. So I'm going to subtract 2x from both sides. And I get 3y is greater than or equal to negative 2x plus 6. Alright, and I'm trying to solve for y here. So I'm going to divide both sides by 3. So we get y is greater than or equal to negative 2/3 x plus 2. Alright, so let's graph this as if this was just an equation. So we have our y-intercept of 2. And we have a slope of negative 2/3. So down 2 over 3. Oops, 3. Down 2 over 3. We go up 2 over 3. Up 2 over 3. And that should be good right there. Alright, so what we can do now is we can okay, so now that since we're talking about inequalities, let's talk about shading, solid line, dashed line, and all that kind of stuff here. And I have a few rules that I've already written down. So let's take a look at these right now. So first of all, we need to first determine, are we going to have a solid line or a dashed line? So if it has a greater than or equal to or less than or equal to, so basically if it has the equal to, then it's going to be a solid line. And if it's just greater than or equal to without the equal to symbol on there, then it's going to be a dashed line. So given that information, we know already then that we're going to have a solid line then, right? So we would go ahead and draw our solid line. Make this guy match up as best I can. Let's see here. Go to about like right there. All right, and we'll go ahead and put arrows at the end of it. And there we go. So now what about the dash part about it? And that's important now, okay? So this is how you know if you're going to put shade above or below. If it's greater than, whether it be equal to or not, it doesn't matter. If it's greater than, that means you're going to shade above the line. So if you have a positive slope, it's up on top. If you have a negative slope, it's still up on top. If it's less than, then you're going to shade below. So coming back up here now, since our inequality is greater than, it's right here, it's y is greater than, then that means that we're going to shade above. Now something that I do want to make a note of, and that is we're not using this inequality right here. Now even though that they're the same right now, sometimes we'll have to flip the inequality if we divide it or multiply by negative number. So we always want to use the inequality that we derived when we solved for y. Okay, and lastly, we can check our answer to see if this is correct. Basically, choose any points that is in the shaded region, and it doesn't matter where at, but just if we choose any point that's in the shaded region, it should make this true. So if I pick the point 0, 1, 2, 3, 4, if I pick the point 0, 4, and if I plug in 0 for x and 4 for y, we should get a true answer. And 4 is greater than or equal to 2. So is that true or false? Is 4 greater than 2? Well, yeah, that's true. So basically, you're always going to get true answers where it's shaded, and if you plug in any answer that's not shaded, that's where you're going to get false answers.